Hey, welcome everybody. My name's Amy Hodler. Thank you for joining another GraphGeeks talk. Today we have a very exciting duo here to talk about RDFs and label property graphs. I do first want to introduce our panel, our experts. First is Dave Bechberger, who's known for his expertise in distributed data and distributed architectures and graph databases. He's got a couple decades experience in and is also in graphs and is the co-author of the Manning book, Graph Databases in Action. He's also a TinkerPop Committer, and Dave, as I always love to remind people, has a wonderful laugh. So we hope to enjoy that today. And then, of course, we also have Jesus Barrasa, who has decades as well experience in implementing graph solutions, also a PhD in knowledge representation. So Jesus has this wonderful academic and commercial experience, so two sides of that coin, and also a co-author on the O'Reilly book of Building Knowledge Graph and a co-host on Going Meta, which is a webcast that he's been doing for, I think, almost 2 years now. So quite some time. So welcome, David and Jesus.
We can give a quick overview of some of the discussions from the other day. The first one would be just in general, what is the difference between RDF and property graphs as far as like how they represent data? And I remember, Jesus, you gave a really nice summary, a couple weeks ago when we talked about like the main difference in the way they represent data, if you wouldn't mind kind of repeating that.
Absolutely. Yeah, no problem at all. So, yeah, I mean, I like to think of it as of course, the two approaches share the idea of connected data, but they work at different levels of abstraction. That's the way I like to think of it. I mean, it sort of makes sense. I mean, the building blocks of the property graph model are nodes and relationships. And these are kind of rich structures with internal elements. Like a node is a collection of properties. It can have a label. So it's the traditional notion of an object from object-oriented programming. And relationships are entities as well that connect two nodes, and that can also have a collection of properties. Now, that works at this level, but the same information can be decomposed in individual statements. So you take a node and you break it down in let's say, subject, predicate, object statements, like this node has this property with this value, this node has this label, this node has this other property, and so on and so forth. So you cannot decompose it in individual atomic statements. And these things also happen to form a graph, but they work at these sort of two levels of abstraction. And both approaches define their own stack, because the property graph has now GQL that materializes in OpenCipher and other property graph query language, and the triple-based one it has Sparkle on it. But I think from the point of view of the modeling, it's down to what level of abstraction you use, which are your building blocks, your entities, and I think that's the way we kind of roughly presented in the previous. I don't know if you want to add something to that, Dave, but.
Yeah, I mean, I don't remember exactly what we said before, but I think my mental model of it is in a property graph. I think of it as almost like I base everything on, my background is just, data in general. So I think in tabular data format. And I think when you think of property graphs, you can sort of think of each node, everything's kind of like a row in a table where as you add additional properties, they come across as additional columns, whereas it's like an RDF is sort of the pivot of that, where you have a set columns. You have, a subject, predicate, object, and graph column. And as you add properties, you're adding more rows. So it's just kind of it's just a pivot on the two is usually the way that I think about it. And the way when I talk to people, that it seems to kind of resonate to them. I know I usually think most people think of data as Excel, the best and worst database that's ever existed. Excel documents. So
that's true. Yeah. And, I think that's a very good analogy. And when you have if you think of, a triple is actually a representation of a cell in a spreadsheet, right? If you look at the coordinates, you will have on the x-axis, you will have some form of ID for the row, and that will be your URI. You will have some an identifier of the column, which will be the predicate, and then you have the object, which is the value for the property. So it's a way of taking the smallest piece of information, which is an atom, which is a triple, and represent it like individually. Now, if you chain triples, that forms a collection, what you typically would store in triple store, and they happen to connect forming graphs, but that's pretty much it. So I don't know if that helps Amy, if that's the kind of answer that you were expecting.
Yeah, actually, yeah, that was a good summary of the discussion the other day. I know we also got in a little bit into this concept of standards, and there's some of the rich standards in RDF and how that's comparable or not comparable to property graphs. And I think that's kind of a good way to look at the differences as well. So Dave, you had some comments. We were talking about OWL and shackle and just like all of these potential standards there.
Yeah, I mean, I think that comes down to when I think about any of these, whether you're dealing with property graphs, whether you're dealing with RDF data, there's sort of like this stack of features that different applications have, where you have, data structures and then schema constraints, things like that built on top of it. And in property graphs, historically, it's really been more about the data structure and has not had some of the other layers above that, the constraint layer, the schema layer, things like that, done as kind of standardized patterns out there. RDF, you have shackle, you have OWL, you have all of these other kind of standards that have been just kind of baked into those applications. Whereas from a property graph side, historically, those have been just sort of either per vendor, per application sort of features, and that's changing a little bit now with things like GQL, PG schema, but those are still relatively nascent technologies. They're relatively new. People are still, as far as I know, nobody's really implemented all of either of those yet. Correct me if I'm wrong, somebody out there, but I think it's a lot of RDF has had kind of standards baked in from the beginning, whereas property graph is kind of has had a data structure baked in and has been starting to add standards as time's gone on.
Absolutely. Go ahead, Jesus.
Yeah, I was going to say that also there's this historic element. I mean, RDF, the origin of RDF was was the vision of the semantic web, right? It was all about interoperability. Let's make data self-describing, available in a way that enables interoperability. So it was kind of in the vision, in the origin of it, whereas property graphs were more about storing data efficiently, querying it efficiently. But it's also important to understand that these, especially when you compare the two, and that's part of what we're doing here today, that these are kind of elements that sit, if you want, on top of the pure data storage and querying, right? So all the data validation, all the inferencing. I mean, not all triple stores would implement inferencing or even shackle. These are standards that exist and that are great because they enable you. They make it possible for you to define constraints and semantics in a if you want implementation independent way. But at the same time, the use of those require additional components sitting on top of your pure data storage triple store, and that's also part of the reasons why you don't have those in the property graph space.
I mean, I guess I would say it's not. There aren't standards in the property graph space, but I have seen, and I'm sure you've seen the same. People build things that are essentially inferencing on top of property graphs all the time. It's just there isn't a kind of a standard set of rules or a standard way to do that.
Absolutely, yeah, totally, and the approach of standards like OWL is precisely, and maybe we go too deep into the details, but the idea is you define the meaning of your data. You define your domains, your ranges, your transitive properties, and there's an engine that understands that that vocabulary, OWL, RDFS for that matter, and they can do something with that so that you don't have to define rules or queries. But of course, the same can be achieved, like you say, in many different ways. So, but yeah, I think we agree on that.
So before we open it up to questions, because I think this is kind of the high level summary we wanted to give people at first. I think, and this is actually one of the first questions from Bob Parker as well, is just about use cases and which use cases might lean themselves for one, more to one data model or another.
Yeah, I don't know. going in first, but just a very quick one. I mean, I think, I tend to insist a lot on in these aspects, but I think it's important to understand the model, the formalism, and the implementation, the data storage, and a number of these use cases are driven by the nature of the store that stores, that manipulates, queries the data, and doing a broad generalization. If you think of triple stores, as we've described, they're essentially a table with 3 columns, 4 columns if you want to add context, but basically that's the type of representation that you will have. Will be optimized in a number of ways, but on the property graph side, you will have some, and now I'm probably going a little bit into the one that I'm more familiar with, which is Neo4j. It has a very specialized native store that focuses on persisting relationships, and that enables a particular type of workload, which is the fast traversals. So if you're doing, and there's a number of use cases along that, if you want to do real-time detection of structural features like a ring, like a fraud element, like doing real-time analysis that involve deep path traversals, that's probably more the kind of workload that you would put in a specialized store like Neo4j. That wouldn't work that well in a triple store. So all this to say, and this is just one simple example, that it's important to understand that sometimes it's not so much this is an RDF use case, it's the store that's behind the RDF. That's the point. I don't know if I helped or I complicated things a bit, but that's the bit that I wanted to. So I would say anything in the direction of path exploration, deep traversals, that tends to be more property graph historically, and less on the RDF. Let's put that as an opening, and I let you continue from there, Dave.
No, I mean, I think that's actually a great way to kind of think about it and frame it. Yeah, I mean, if I'm dealing, I work on the Neptune team, and we support both RDF and property graph. So we see a lot of these sorts of questions come in, and it is a lot of times. I mean, if you want to do path traversals and you want to basically return not just that things are connected, but how they're connected, just the nature of the query languages also drive a little bit around what you're trying to do. It's very easy to get a path back in something like Gremlin or OpenCipher, and pretty much impossible to get it back in Sparkle. You can get back that they're connected, but not how they're connected. So I think your thoughts there are great. But also, on the other side, where you have data, maybe you have a use case where you need to be able to connect. Maybe it's a master data management use case, or I'm going to use knowledge graph use case here in a very specific way versus kind of the general way I think a lot of people think of it. You have a knowledge graph use case where you have many different data silos you want to connect them together, or you want to be able to federate into other external data sources. A lot of times we see customers use RDF for that sort of thing, because it's sort of by the nature of the way that the constraints are built into the model of an RDF database. They're very easy to be able to do that, because, as I think we've kind of mentioned here, didn't necessarily go into detail, like one of the features of RDF is, everything's represented by an IRI. So there is a globally unique identifier for each piece of data inside of your system. And being able to have that makes it very easy for, connecting data across different sources, different databases, things like that. And those kind of lean towards RDF. But a lot of times we also see people that want to use data as, graph data as more of a data structure versus kind of, a knowledge representation, lean towards the property graph. So, I mean, I don't know that it's particular use cases that, you could do fraud, and you could do fraud detection in either one. You could do customer 360 in either one. It's really kind of, what is it, you have to kind of go down a little, almost to the next level of what sort of questions do you want to be able to ask of your data in order to be able to kind of help with that.
So Dave, I feel like that, and Jesus, this kind of leads to the next question. I'm going to be opening up audio and video for everybody now, so they can ask their question. But as I'm doing that, what you just said kind of leads to the classic, how do I choose? What do I need to think about? I'm not sure where to get started. We had a really great discussion about stack and layers and things like that the other day. So if you can kind of answer that, like, or at least directionally, help with that question as I open it up for voice, that'd be great.
Right, I suppose that's the $1 million question, right? So it's, I think again, I would let's say I insist on the detaching the storage from the model, because ultimately, and again back to the origins of RDF. RDF is a model for data exchange, for interoperability. So ultimately you could persist RDF not only in a graph database but also in a relational database. I mean, there are bridges that can support that. So that's not, to me, the driver in this case. It's mostly, what's the store behind? What are the characteristics? What's the level of high availability that your solution require? What's the syntax that you're comfortable with? I mean, some people might work well at this property, let's say statement-based level, so with languages like Sparkle. Some other people might feel more comfortable with languages around OpenCipher and GQL, because they're closer to the object-oriented approach of. So I don't think is open source a consideration. What's the story around integration? What's the ecosystem around the platform? I mean, I tend to look at it more from, as an engineer, as a software person who's going to develop that, rather than maybe other possible angles that people might have. But I think these are key questions that you need to consider before you choose one or other stack.
Yeah, I mean, I would fully agree. I think it's more than just the data model. It is all of the, to your point, the ecosystem around it, what tooling you want to use. In a lot of companies, it's what familiarity does your developers have with different technologies? What are the easiest, has the easiest on-ramps? In some cases, if you're using commercial things, what does your business allow you to use? So I don't know it's as easy as saying, for this type of use case, it's always use this. Unfortunately, I think there's a bit more that goes into it than that. But I think, in general, to me, it comes down to really, how do you want to interact with your data? Do you want to interact with your data in kind of the more classic database version of using it as a data structure to be able to do a data store, in which case property graphs would probably be the way I would lean people towards. And we tend to find that, especially if you come from like the developer side, that tends to be a lot of the way customers think about their data. That's so it's more natural for them to use a property graph. Whereas if you come more of a knowledge representation background, or you work in an industry where healthcare, for example, there's a lot of industry standard kind of RDF data sets already out there. Being able to use those and leverage those inside of your application and tends to add a lot of value.
It's one of my big takeaways from where the conversation the other day, and actually even now, just that the decision point, you have to think about. I've always thought about RDF and property graphs as like the data model, evaluate the data model, but that there's many layers to that decision, tools, what people are familiar with, as you both have said, what you have to integrate with, that it's kind of more thinking about it almost as a stack of technologies and tools and capabilities, as opposed to just the data model, which helps me put it in context of, it's a bigger decision than just the basic data model.
Yeah.
So
I would also say that's an area where people tend to conflate the two. A lot of times you hear people talk about RDF data as really mean RDF databases, which is kind of the whole stack. RDF data at its very core is triples. It's not Shackle and Owl. That's layers built on top of that context, or that data model, I should say.
So we have our another typed in question, but for those that are okay, we got lots of thumbs up. So feel free to raise your hand, or just take yourself off silent mode and go for it. And we have our first raised hand. Who is this? Paco, you've got a question. Why don't you go ahead and go for it, and then we'll go to the one in Q&A. So go for it, Paco.
Thank you very much, Amy. I appreciate it. Great discussion. I really love this. One thing I'm curious about, if you've seen, can you characterize maybe any differences you've seen in graph enhanced RAG using either RDF or label property graph as the graph? Are there pros or cons?
That is a very good question. I mean, I think I'm going to, of course, answer that from my point of view and the experience that we get at Neo4j. So a very important element of the type of graph RAG solutions that we see is relies on the fact that we need a good description of what's in the graph, right? So we need to understand if RAG in the general case will involve probably two things. I mean, generating queries on your database based on the natural language question, or maybe do some kind of vector search exploration plus contextualization. So and both rely on a good understanding of what's in the graph. So one would say, well, again, property graphs, they're self-describing in the sense that you can retrieve the schema, introspect the schema out of the database. So it's one of those cases where you kind of have the ontology built into the data. I can query an Neo4j database and say, give me the types of labels of entities and relationships and properties that exist in it. And that's the information that you need to either generate those questions or contextualize the vector search. I understand that, and again, I'm doing building a hypothesis here, that on the RDF side, rather than doing it like that, you would require an explicit ontology to exist and describe precisely what this model looks like. So would that be a different? Do you have an opinion on that, Dave? Is that what you're seeing on RDF type?
I mean, I think really the key part there is what you already hit on is whether it's an ontology or whether it's an introspected schema from a property graph or an RDF. Really, the key for any LLM is to feed it that sort of schema information that really helps guide it for what it's doing. So I think whether, I think it also depends a little bit on what you're trying to do there. If you're trying to do things like natural language querying, my experience is actually like there's a lot of Sparkle examples out there. There's a lot of Sparkle examples that have been around for many years and that LLMs have been trained on. So they tend to work reasonably well to try and do that versus something like Cypher, OpenCypher, Gremlin that is just, relatively new in the world of that, relatively small amounts of examples out there. They tend to work okay. They tend to have a little bit more challenges. Those are getting better over time, in my experience. I think the other part here is, if you want to do something like generate a graph out of a set of documents, which is kind of one thing I don't think you specifically kind of mentioned. Yet again, having that sort of schema, being able to tell it what you want to do helps. So having, some sort of maybe, if you're looking at financial documents and you want to use kind of an existing ontology, something like FIBO or something like that, that the LLM may already be aware of, most likely, does help from that perspective as well. So I think I don't know that one is better than the other. I think it really comes down to in either case, you need to be able to describe the schema of your desired graph or the schema of your existing graph in order for LLMs to really understand how, what sort of information you're looking to get out of them.
I would just add one data point there, because it's true that Sparkle has been around for way longer, but it's interesting, and we can take different proxies to understand which is the one that's more used and therefore provides more examples for training. But there, I think they're surprisingly close, and if anything, there's and again, I'm not pitching here or anything, but there's more Cypher around. If you look at, for example, I don't know, Stack Overflow posts, right? So there's a significantly higher amount of those tagged as Cypher or Neo4j than Sparkle or RDF. But that's again, I agree on the whether LLMs are better at writing Sparkle, SQL, or OpenCypher is one thing. But I was focusing more on the vocabulary, the schema elements, right? Models can understand the structure of a Cypher query, but putting the arrows in the right direction, using the right labels, using the right properties, so I think that's what I mean, and that's what has to be exposed from the graph for the LLM to be able to generate valid queries. But I don't know if Paco was focusing on that, or also on the property graph construction as well, because that's another important angle, right? So because when you referred to graph enhanced RAG, it can be looked at from many different angles. I don't know, anything you would add, Paco, on that?
Well, I mean, it's great points. Thank you very much. And certainly GraphRag is a very overloaded term. Ben Lorica and Prashant Rao did a really nice article about just how overloaded. I think it means like 5 things at last count that I've seen. But you've touched on the main. I mean, there's the point of, we need to construct a graph possibly out of the same docs that we're chunking. And I think that the libraries so far have been kind of naive about that. They haven't been as sophisticated at graph building KG construction as they could be. So, more work, more fun to be had. But then the important part of like decomposing a prompt into queries, I think you both made really great points about that. The third part, though, I think is less explored, but we're starting to see where, the benefit of using graph enhanced RAG over like a vector DB RAG, a lot of the benefit I see there is that you can get non-trivial connections. You can explore the multi-hop because this is something that vector DBs are going to skip. And so being able to do like a traversal, a semantic random walk from some starting points based on your prompt, this is really important. My hunch is label property graphs probably support traversals better in that sense. But on the other hand, I could really see cases for using something like transitive closure and really gaining a lot if you have the right controlled vocabularies to leverage there. So my 2 cents, but thank you very much.
Well, I would add maybe one other thing to that Paco, which is not just multi-hop queries, but one of the big areas we also see customers are interested in is being able to explain why the answers, why you actually got back the answers, and especially if you wanted to use rags and graph rags and some sort of regulated industry where you need to be able to basically say why these 2 things are the pieces you came back, why it was summarized the way it was is I think another key part. And in those sorts of scenarios, I think that kind of comes back to that pathing question in a lot of ways too, where being able to explain how they're connected, not just that they are connected.
So I think that and I will say, just back to the why, I'm super excited about causal graphs right now. So that's another topic for another day. But one of the things that I do want to ask as well, Joseph, I see your question about RDF and LLMs. I think hopefully we've answered your questions. If not, add more or take yourself off mute and just ask. But that also leads me, this kind of Gen AI, LLM, and graph conversation leads me to ask about inference as well, because what's a question we hear a lot is like, are RDFs more suited or more natural for inferring, and therefore will have a lot to add to the whole Gen AI conversation. So I like to hear a little bit from both of you on the idea of inference in both the 2 models.
I mean, I would say I can maybe start this one. I would say inference in RDF there's a few defined mechanisms to be able to do inference. So I think it's built in naturally to that model. Whereas in a property graph, it's something that there isn't a standardized way to do this. So you have to build the inference yourself. But in both cases, you can absolutely do inference with either type of model. I don't know that it's as much of one is better than the other, as much as in RDF, there is kind of more of a standardized mechanism or mechanisms to be able to handle that. Jesus, what are your thoughts there?
Yeah, totally. That's and there's a data point that I've never managed to get, and I'd love for any of the triple store vendors out there that support ontology-based inferencing to understand what's the level and the extent of its utilization, because I in my experience, I mean that's something I've done over the years, but I still see it as a complex approach. I mean, I'm not saying there's no value, but I would like to hear, and to see where we are at really, because that exists and that's sometimes used as an argument, and maybe some of the attendees can give their opinion here. But I don't see it as a really practical approach. What we see normally is more kind of the traditional rule-based approach. I mean, I kind of define an open cipher expression, a sparkle expression, and I can use that to enhance the graph. There's even machine learning based approaches to do link prediction. So there's many ways in which some of them are more symbolic, more like, this is the instruction, this is the pattern that when you find, if my dad has a dad, he's my granddad. That's the rule. That's the simple example of the kind of things that you can do when you're explicit and when you're symbolic. But there's other things that, you can learn and predict the chances of me being linked in the future in LinkedIn with Dave. I mean, that's something like that, right? So there's many that inference is again another overloaded term, and there's many ways to do that. I suppose for the RDF people that historically means a lot ontology based inferencing, and well, it's one approach, one of many. So from that point of view, yes, ontology based inference, ontology as in OWL, RDFS, etc. It's exclusive, I would say, not because it's technically impossible, because no one has implemented OWL-based reasoning, as far as I know, over property graphs. Maybe there's some library out there that does something like that, but I haven't seen it.
If there is, I would like to see it. It would be very interesting. I think that would be a very powerful addition to a property graph, but I'm not aware of one either.
That sounds like we could do a whole session on inference. Veronica, you had your hand up very briefly.
Yes, I did. But then I heard my kids arguing in the back, so I lowered it down again. But anyways, I just wanted to add on the inference thing. And what I see as the really unique thing about semantic knowledge graphs on RDF is actually inferencing and be able to do logical deduction in data and the reasoning capabilities. Is what differs RDF from anything else, and I find it quite powerful. And it doesn't have to be like heavy shit description logic, like these very complex axioms. It could be as simple as classifying individuals based on the description of classes, and that I do very much at my client projects in Capgemini. So I just wanted to add that comment.
Sure.
Thank you. And I don't see any other hands up, so feel free to speak. Oh, now we've got one. Let's see here. Dennis, you have a question. Awesome, Dennis.
Yeah. Hi, Dave. Jesus. Yeah. So this is actually different from what we're currently talking about. It's just question in general about RDF and LPG. Yes. I've listened.
If you get your audio back, Dennis, just raise your hand. We'll bring you back for the really great question. We've got you.
Okay. Can you hear me now?
Yes.
Oh, okay. Sorry about that. Yeah, so I think the question I want to ask is, so how do you foresee the future of RDF and LPG in the industry? Do you see a role where we can actually combine both of them in, let's say, in within an organization, or maybe to solve some problem, because they both have the strengths? And is it possible, in any use cases, where we can actually optimize both of them in a particular workflow? Specifically, Dave, you said Neptune supports both RDF and property graphs. So have there been any scenario where, some, let's say a client, or let's say a project or a product is actually leveraging both RDF and LPG? Because I think that would really be wonderful.
Yeah, I mean, I sort of kind of heard two questions there. One, do we see people using them together? And then two, do you see you see the kind of future going for those two? I mean, I think from the do people use them together? We absolutely do have customers where they're using both RDF data as well as property graphs inside of an organization for different purposes, different groups. I think it comes down to, different groups have different needs. So different groups have different backgrounds, different skill sets, and they, in a lot of ways, they will choose the one that kind of solves their problem the best. I mean, that's the way we usually kind of work with customers to solve that. And it's not, in both cases I've kind of discussed, there's pros and cons to each of these, and understanding the stack and how that works is kind of key. And I'll let Jesus maybe chime in here as well.
we have a bunch of, I mean, the coexistence is inevitable. I mean, there's use of RDF in large organizations and property graphs at the same time. The integrations can take different shapes, but yes, we see that being used together. So yeah, typically, one is more leaning towards the knowledge management side of things, and the other one more kind of making data more operational. But yes, we have a number of projects where the two are used. I mean, I'm trying to think one example, and I'm looking at the questions at the same time, and I see Katarina's name mentioned there. Someone said that I don't know when was that, but there was a recent talk where she was. That's a great example. I mean, at IKEA, there's a good bunch of users that are very familiar and use RDF, but they also use Neo4j for different users. And there's ways of integrating them, and that's kind of I think the best of both worlds. And it's interesting because that one talks about data log, which is a similar idea to the one that we were talking about. Is it yet another way of running inferences, right? So it's like more rules based. But again, and I don't know where she mentioned that, but this is yet another way of getting something like what Veronica was saying. Maybe she finds, using ontologies and finding, I suppose when she said classification is probably based on, domain and range style, you can classify and infer the type of entities based on certain properties. I mean, it looks like Katarina was using something like data log rules to do something similar. So, I mean, kind of took a divergence here at the last minute, but there's plenty of examples where the two exist, and I, to be honest, at least the near future, I keep seeing coexistence. I don't see anything different than that.
Awesome. And I see another hands up from Joseph.
So, in a world where we have a lot of financial regulations, for example, GDPR is really focused on having data localization. How will we use graphs to solve cross-border business use cases?
Well, I guess that's not just a graph problem. Maybe you can elaborate on how graphs could be different from that point of view. Maybe like a graph partitioning in some way.
Yeah, I can give you a bit more context into it. So I'm from a financial background, and what we currently do is we collect data from multiple countries, put it in a refinery, and do analytics on that. Okay, and we majorly focus on RDF graphs. But since these regulations are coming into picture, I don't think that's quite feasible in the long run. So as an organization, we do find challenges on how to resolve this by not increasing risks.
Yeah, I mean, I think my thoughts on that are very similar. This isn't. I wouldn't say this is unique to a graph problem. It does kind of come down to a data partitioning sort of PII type problem, especially when you want to deal with data sovereignty. Well, I guess there's two parts. There's like data sovereignty, and then there's like GDPR. Both kind of have their own challenges associated with that sort of information. I mean, it's hard to say exactly how a graph is going to be. How specifically you need to implement it. I mean, one thing you do have if you're working with RDF data is the ability to federate across different graphs. So you may be able to leverage some of that technology or that technique in order to be able to have data located, for a data sovereignty sort of thing, have it located in its home country but still be able to analyze it from different areas. But from like a GDPR sort of fundamental piece, I think it's not exactly the answer to your question, but I think being able to use graphs to track data lineage, where that data is being stored, where what information is being stored, where it's being transformed, where it's being used, is kind of a key part of being able to support those sort of CCPA, GDPR type regulations. So maybe not an exact answer to your question, but another way where graphs do benefit those sorts of use cases.
So it sounds like, this is another one of those situations where I've heard you both say at the end of the day, it's just a graph. That if the graph it's not a specific, if a graph makes sense for you, evaluate that first, then look at that ecosystem, look at your team, and try to figure out like which model works for you. But always starting with, do you have a graph problem? What are you trying to do first? So that's probably a good pivot maybe. And Hoisin, I saw your email of questions ahead of time. So if you want to ask some of them live, please feel free to do so. But before we get in, you had a lot of detailed questions on queries and query languages. So, but before we go in that direction of that kind of detail, I thought maybe this is a good time to talk about the misconceptions and the common misconceptions that you both hear, because I'm sure we all have some of those, or our favorite misconceptions.
I mean, there's lots of them. Let me. I mean, it's not a misconception, but it's kind of a, and I'm sure but this idea of integration. I mean, Dave, you were talking about it before. Like, probably RDF is understood as probably the natural approach to integrating data from different sources in a kind of a, let's say, DBpedia style approach, right? So because there's the notion of unique identifiers, well, then linkage will happen magically. And I'm not saying that's what you said, but that's sometimes what you tend to hear, right? Yes, you do have unique identifiers and things will link together as long as you use the same unique identifiers, which is typically not the case. And that's exactly the problem, right? So it's naive to think that if you put data as RDF together, that will link nicely and magically. That will coexist in a graph, but it will be a disconnected graph, and that's where you will have to do inferences of the type that we discussed before. Like, if whatever, there's a property that's actually a unique identifier based on the name or whatever, you can derive that these two things are the same, and you might want to link them with the same mass relationship or unify the URIs, whatever you want to do. But this idea of putting things in an RDF graph will suddenly, some magic will operate and link things together, is obviously naive, is a misconception, and it's incorrect. I mean, it's like that's one that I tend to hear quite often. Can give you more, but let's take turns. Go for it.
No, I think even just to add on that, the flip of that is also true. There's nothing that says you can't integrate data across property graphs as well. I mean, that happens, and I'm sure you see it many times, much like we do, where you integrating it. It's not, the RDF data came from the idea of being able to, link data across the web. So it does sort of have some built-in functionality kind of baked into the data model, as we kind of mentioned with the IRI. But there's no reason why you can't do that same sort of thing with a property graph if you want to be able to use that together. But the other one that we have is that, once you've chosen one, that's the only one that you should use there going forward. I think that kind of comes back to make sure you choose the right technology to solve the problem you have. I mean, I always like to kind of say, all databases and all data is a key value store with useful abstractions built on top of it. Make sure that you're choosing the right useful abstraction that helps you solve your problem the best. If your problem is best solved in a relational database, use it. If it's best solved in a graph database, use it for that. And make sure you're choosing the right technology and not just using a graph because it's a graph problem.
True. Another one that I believe we've touched briefly in the previous session was this idea of ontologies are schemas. That's wrong. I mean, people perceive and I don't want to be a purist and like someone who I understand, and we have to be pragmatists, and in the end we're solving problems, right? So, but again, there's this assumption that if I define my ontology and then my data will align with that model. Well, that's again. Ontologies are not constraints in the traditional sense of the term that was used in relational databases. An ontology will not prevent you from, if you've described that the property name is connected through the domain relationship to an entity of type human, no one will stop you from entering a cat that has a name, and that's absolutely fine. And so ontologies are descriptive. They're not constraints for that. There are other formalisms like shackle that has been mentioned before, but yeah, people tend to think like, I want to define an ontology and I want my data to align to that ontology. Well, these are two separate things. Maybe the ontology might be potentially used to create your data ingestion pipeline, and therefore your data will align with the ontology. But it's not a constraint. It's never been a constraint. Is kind of an entirely different thing. It's more descriptive, and like I said, a driver for inference rather than a way of prescribing the shape of your data.
It's more a list of validation rules that you can run against your data to say that it does match this or doesn't match this. But
You can certainly, I mean, because that's the powerful thing, because ontologies are data. It's data about the data, it's metadata, but it's actually data. You can precisely, Dave, like you say, you can write a query that says, do you have a property that doesn't show in your ontology? You can query that. That's pretty powerful, as opposed to constraint in a relational database that, it's not something that you can query along with your data. So that would be a pretty meta type of use, but yeah, you can do this sort of thing. But that's a common misconception, in the sense that, ontologies are not constraints.
I think my favorite is you get, like, there's so much discussion around semantics and the importance of it, in that you automatically get semantics with RDF would be probably one of my favorite misconceptions. I wish there was such a magic bullet, but you still have to do the hard work to, develop. All right, so we do have a question from Hossein, and I know he sent some ahead. Can you go ahead and ask those questions, or your question, Hossein?
Thanks a lot. I will just ask one of them, since we just discussed about this validation and some approach to just something like shackle for RDF. We talked in the talk, you didn't mention a lot about PG schema. So the paper is for a year ago, and I don't know if GQL is also covering some aspects regarding validation. So I just want to know what is the state of PG schema, or having a schema mechanism for.
Right. So I can talk very little about it, because it's not an area where I've done a lot of research. I know this is still work in progress from the definition point of view, and from the implementation, we're only early stages in now I'm talking about Neo4j, the implementation that I'm more familiar with. So, and those would be, prescriptive sort of constraint style definitions, right? So yeah, I'm sorry I cannot give you a lot more detail. I mean, on the implementation side, I know that there's work in progress, and that we should see things from here around the end of this year. But that's as much as I can share. I'm not super familiar with that side of the standard.
Yeah, I mean, I think I'm kind of in the same boat. Like, as far as I'm aware, PG schema, there've been some initial work done on it. There's been an initial paper put out. I don't know that it's even completely finalized. I think there's still a lot of work that's ongoing in that area to really kind of make that a bit more formalized. And as far as I know, nobody yet has implemented it. Anything, from at least in any of the commercial or open source ones I'm aware of.
And I will say, if you haven't already been on the GraphGeeks Discord channel, we have a couple people on there that have been part of the GQL or GQL. I never remember which way I'm supposed to say that, but from the standards there, and that deal a little more with the query languages. So you might have some opportunity to ask some questions there. And in the future, I think a session just on query languages is probably also warranted, because there's just always questions around that. Another question that Hossein had noted in prior to the session in email was about transferring or transport between label property graphs and RDF, between the different languages, Sparkle and property graphs, and even the One Graph initiative, which is kind of exciting. Well, so just in general about like how you go from one language to another, or one standard to the other. I know we talked a little bit about that, but I don't know if you can, maybe highlight some of those transports. Neo-semantics, for example,
Well, I definitely can talk about neo-semantics, which is basically just, for those that don't know, it is just a bridge that can ingest RDF data and persist it as property graph data in an Neo4j implementation. And it's based on a very simple idea. Like I mentioned at the beginning, node is from a triple point of view, is a collection of triples with the same subject. It's as simple as that, right? So that's the kind of aggregation that it implements. And it's simple because it understands RDF as a mechanism for data exchange. So the persistence layer is Neo4j, is a property graph, and therefore the querying is on the persistence layer, which is via Cipher. So that's one form, limited form of interoperability, right? Because you can generate data, RDF data out of a property graph, or import RDF data. But there's no support for Sparkle, because the data is persisted in a property graph form, and therefore the querying is the one offered by the storage layer. So, but there's maybe you want to say a couple of words about the one graph approach as well.
Yeah. No, yeah. So the Neptune team, for those not familiar, wrote a paper a couple of years ago talking about an approach that they have around the One Graph initiative is what we call it here, and it's a little bit different than something like neo-semantics, which is really ingesting RDF data and storing it as property graph. And the One Graph initiative is actually more of a unified persistence layer that would allow you to be able to store the data one time and query it using different query languages. So you could load the data one time and query it via Sparkle or via Gremlin or via OpenCipher on top of that, and that's still still a work in progress. It hasn't fully reached maturity yet, but it's sort of a different approach to interoperability than something like neo-semantics does. But I think it's an area that as the graph space matures, that being able to have a defined kind of, or at least a few defined areas of interoperability between these is going to reduce the barrier to entry for someone. Because right now, as we've seen here, there's a lot of questions of, do I use RDF or do I use property graph? And trying to remove that upfront decision for people.
So as we are wrapping up, we have 2 minutes left. So I will ask both of you if you have some thoughts you would like to leave people, suggestions, recommendations, or just like generally how to think about things. I will say my thought and my takeaway for everybody is that it's a layer, it's a stack, it's an ecosystem when you're evaluating one versus the other, not just the data model. So that's my one takeaway my most important takeaway, I guess, from these conversations. Dave, how about you? What's your summary or thoughts for people?
I mean, I think I've echo a lot of what you said there, as well as the ability to make sure that choose the right technology that solves your problem. Don't worry so much about the low level of, is it a property graph, is it an RDF? Really understand what the problem you're trying to solve, and then work backwards to figure out the right technology to actually solve that problem the best.
Totally. I couldn't agree more. I mean, we're ultimately trying to solve a problem, and if you think of it, we're talking, at the bottom of the stack. I mean, it's a kind of an implementation question. It's more than that. I agree. But start with by the question, but the problem that you're trying to solve. And ultimately, I hope these conversations like these ones are informative and give some pointers on how to analyze the problem and make a decision. But ultimately, what I would say is always, don't take our word for it. Just go and try it, because that's ultimately what will give you the right answer, right? So just go and try it is the what I would say.
Thank you both. Appreciate the time and everybody sticking with us with these great questions, and we'll see you all on GraphGeeks in the future. All right, thank you, everybody.
Thank you.